Hello, students. Hello, everyone. Welcome to today's tutorial series in physics. And today we'll be diving into a very fascinating world of motion. And we will be exploring the concept of speed, velocity, and acceleration. And by the end of this lesson, you have a solid understanding of these essential physics concepts and how they apply to everyday life. So let's get started. My name is Mr. Emmanuel, and I am your physics teacher. So what's our learning objective for today? At the end of this class, you we understand the concept of speed, velocity, and acceleration. You will differentiate between speed and velocity, and then you calculate the velocity, speed, and acceleration using given formulas. So that's a learning objective for today's class. First, let's talk about speed. But I'll introduce you. Imagine a world where nothing moves. Everything is just static. No car moving, no humans moving, no planes, no ship. Just imagine a world. That sounds boring, right? I know you in the deepest of your mind, it sounds very boring. But now think about your daily life filled with motion. That's another level of excitement that will come in. For example, running to catch a bus as a student, leaving your home, maybe you are late for school. You just have to run to catch the next bus that is going towards your direction, or biking to school, or driving with your family for a holiday, a feast, to church, or wherever you're going to, or even watching a plane soar high. That's a very interesting sight to behold. So, but now, but how do we measure all of this movement? And that is the object of today's lesson. So let's dive into the exciting journey of understanding speed, velocity, and acceleration. So first, let's talk about speed. Let's talk about speed. What is speed? How do we measure speed? How do we compare speed? What is speed? So speed is a measure of how fast an object is moving, how fast an object is moving. So it tells us the distance an object travels over a certain period of time. Now, let's take a story of this young man, Timmy. Timmy loves to run, and he wants to know how fast he can run to the park. We call this speed. And speed is the measure of how fast an object covers a distance. How fast an object covers a distance is called the object speed. So let's see, what's speed? Speed is the rate at which an object covers distance, the rate at which an object covers distance. And we can use simple equation to calculate speed. And that equation, speed is distance all over time. Speed is distance all over time. And we can see, and from that equation, we can get the unit for calculating speed. Now, distance is a length, and the unit for calculating distance is the meter. So distance is the meter. You can see the meter. And then time is measured in seconds using a stopwatch. Now you can see speed is distance over time. So we can say the unit for calculating speed is meter per second. So this division sign in science, we'll call it per. So meter per second is the unit for calculating speed. So unit for calculating speed is meter per second or kilometer per hour. Well, distance can also be measured in kilometer, and time can also be measured in the unit for the hour. So kilometer per hour. So let's move to the next concept. Now let's look at an example of how speed. Let's solve a problem with that. Example, Timmy runs 100 meters in 20 seconds. What is his speed? Timmy runs 100 meters in 20 seconds. What is his speed? So for us to calculate speed, we need to get the distance and time. So the distance is 100 meters and the time is 20 seconds. And our speed formula is distance divided by time. So let's look at some parameters that the question has given us. The question has given us distance to be 100 meters, time to be 20 seconds, and we have to calculate the speed. So we solve speed by making substitution into the speed equation, which is distance over time. So our distance is 100 and our time is 20. So 100 divided by 20 gives 5 meters per second. So Timmy is running at 5 meters per second. That is the speed, and that is how fast he is running. Wow, quite interesting. So let's look at, this is your turn. Give you some minutes to calculate the speed. Timmy wants to challenge you. And are you ready for that challenge? He ran 50 meters in 10 seconds. Can you calculate the speed? So let me give you some seconds to do that, to calculate the speed. Well, great, great, great. I know you got that answer right. So let's check. We've been given this parameter. The distance is 50 meters. The time is 10 seconds. So what's the formula for speed? Is distance over time. And then we'll make substitution into that 50 divided by 10, which is 5 meters per second. So Timmy is also running at 5 meters per second. So the next concept will look at the different kinds of speed that we have. There are different types of speed to consider. And we have the uniform speed. So when an object moves at a constant speed without changing, we say that object has a uniform speed. We have variable speed. A variable speed is a speed that changes over time. So it's not constant, it changes over time. That is a variable speed. Average speed is a speed that the total distance is divided by the total time. The reason why we have the average speed is that a car may be moving in a road, and you experience traffic at certain point. It has to slow down, reducing its speed at different intervals based on the situation it meets along the road. So for us to get the average speed of that journey, we need to look at the total distance covered by the car and the total time it took the car to cover that distance. So the total distance divided by the total time is what we consider as the average speed. And we have the instantaneous speed. So the instantaneous speed is the is the speed at an instant in time, and that is what is being recorded by the speedometer in a car. So let's look at examples of these different types of speed. For uniform speed, we have like a train moving steadily at 60 kilometers per hour. For average variable speed, a car that is stopping and starting in traffic, that is variable speed. Average speed, like a road trip where you travel 300 kilometers in 5 hours, that is an average speed. And then the speed at a specific moment in time is that is being like the one your speedometer reads is the instantaneous speed. Okay, so lesson, for example, a car moving steadily at 60 kilometers per hour demonstrates uniform speed, while a car stopping and starting in traffic shows variable speed. But when you look at the speedometer, you are seeing the car's instantaneous speed. This is very cool, very cool, very cool. Now let's answer these. So it's your turn to answer this. I've done the first one. For a car that speeds up and slows down due to traffic, have a variable speed. So a train traveling at a constant speed of 80 kilometers, what type of speed is that? What's your answer? I know you got it. So the answer is uniform speed. Let's see, reading the speedometer of a car at particular moment. What is your answer? What type of speed is that? I know you got it. It is instantaneous speed. And the overall speed of a trip covering 150 kilometers in 3 hours. I know you got it. What type of speed is this? Yeah, you got it. It is the average speed. So we'll move to the next concept and we'll look at an example on how we solve average speed. So let's say you take a trip from city A to city B. The total distance between the two cities is 300 kilometers. You spend 4 hours traveling to city B. During this trip, your speed varies due to traffic condition, stops, and challenges in road types. So to find out your average speed for the entire, you use the formula for average speed. So formula for average speed is total distance over total time. So let's see our given parameters. The total distance is 300 kilometers and the total time is 4 hours. So our average speed is 300 kilometers by the 4 hours, which is 75 kilometers per hour. Excellent and excellent. So we'll move to the next concept, our understanding velocity. Understanding velocity. So next, let's explore velocity. Velocity is speed with a direction. Wow. You say speed with a direction. What do I mean? Can speed have direction? Yes. Whenever you attach direction to speed, it becomes a velocity because velocity is a vector quantity. Vector quantity is a quantity that has both size and direction. Both size and direction. And what does this mean? This means that the velocity tells us not only how fast an object is moving, but also in which direction the object is moving. Remember, speed only tells us how fast the object moves without making reference to which direction. Is it moving backward? Is it moving forward? Is it going upward, downward, east, north, west, south? All these are directions that the speed does not consider, but the velocity considers these directions. So can define direction and speed, velocity as speed with direction. So Bella loves biking, especially to the north end of town. Velocity is like speed, but it tells us the directions too. but Bella bikes 200 meters north in 40 seconds. How do we describe her velocity? Let's get to know that. So velocity is speed in a given direction. Speed in a given direction. So the formula for calculating velocity is displacement over time. Take note, it is quite different for the formula for calculating speed. Speed is distance over time. So someone may ask me, what's the difference between a distance and displacement? So distance is a scalar quantity. Like the speed, distance only gives us size, no direction. For example, I can walk 5 kilometers. I can travel a distance of 5 kilometers, but you don't know the distance I moved, the direction I moved. Did I move towards my door? Did I move towards the kitchen? Did I move northwards or what? No idea of that. But displacement will tell me the direction. So we can say displacement is also a distance with direction. So the displacement has both sides and direction. And since velocity has both sides and direction, in the formula, we're using that velocity is displacement over time. You can see in the image, this young lady is moving at, you can see 20 meters in 40 seconds. You can see the direction, the arrow showing the direction of her travel. So the unit for measuring velocity is the meter per second or the kilometer per hour. It has the same unit with speed. So its example is, as you can see, Bella's biking speed and direction gives us a velocity, as you can see in the image. So if Bella travels at this 200 meters north in 40 seconds, her speed is 5 meters per second. Due north, because so the north here gives us the direction. So we have to include the direction. The magnitude is 5 meters per second, which is the size, and the north tells us the direction she is moving. It's your turn. Bella back 300 meters is in 60 seconds. Calculate our velocity. So let me give you some time to calculate this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know you got that. So let's say this is Bella. You can see 300 in 60 seconds. So the given parameters we have, the displacement is 300 meters east and the time is 60 seconds. So the velocity is displacement over time. So our velocity now will be 300 divided by 60. So which is 5 meters per second. So Bella is moving at 5 meters per second in the northern direction. So you have to include in the eastern direction. So I'm including the direction here, east. So she's traveling eastward, 5 meters per second east. That is our direction. So let's move to the concept of acceleration. Acceleration. Now, let's talk about acceleration. What does acceleration mean? Acceleration measures the rate at which velocity changes. Yeah, the rate at which velocity. So our velocity can change. For example, Bella may be running at 5 meters per second, walking at 5 meters per second, and she needed to catch her train. She increased her speed to like 10 meters per second in order to get. So that increase in speed for that time is an acceleration. So an acceleration is the rate at which velocity changes. So in other words, the acceleration tells us how quickly an object speeds up or slows down. Remember that word, how quickly an object speeds up or slows down. So the formula for acceleration is change in velocity with time. Okay, so let's look at this scenario. The car can go from 0 to 60 meters per second really fast, miles per hour, really fast. This change in speed with respect to time is called acceleration. So let's see how car speeds up. You can see Carl's car. This is Carl inside his wonderful car. And acceleration is the rate of change of velocity. And the formula for calculating acceleration is change in velocity. So the unit is the meters per second and squared. So acceleration is also a vector quantity like the velocity because it has both direction and size or magnitude. So alongside with its size, it includes direction. So acceleration is a vector thing. So let's see how this okay, let's an example of this. So the car can go from 0. So this change in speed is called that. Let's calculate our car. So find the initial speed of velocity is 0 meter per second or miles per hour. It was given in miles per hour. So I'm correcting this quickly. So this is 20 miles meter per second. Yeah, this is 20 meter per second. So cars is moving at that 20 meter per second and it's really fast. So let's see, how do we calculate the acceleration? The acceleration is change in velocity with respect to time. So we need to get the change in velocity. So the change in velocity is the final velocity minus the initial velocity. So the final velocity is 20 meters per second. The initial velocity is 10. So we're doing 20 minus 0, which is 20 meters per second. So the change in velocity is 20 meters per second. So make substitution into the formula of acceleration. The acceleration is change in velocity over time, that's divided by time. So 20 meters per second divided by 5 seconds, which is 4 meters per second. You can see it from the image. The time has been given to us these 5 seconds. So we are assuming it took 5 seconds to cover that distance. So let's look at acceleration. Let's look at acceleration. Acceleration so this is your turn to calculate the acceleration. Your turn to calculate acceleration. So I want you to do that quickly. So Carl accelerated from 5 to 30 meters per second in 30 meters per second in 10 seconds. Calculate his speed. Calculate his speed. So let's calculate his speed. Let's bring out our parameter well that the initial velocity is 5, the final velocity is 30, and the time taken is 10. So we need to get the change in velocity, which is in final velocity minus the initial velocity. Final velocity is 30. Initial velocity is 5. So subtract those two. 30 minus 5 is 25 meters per second. So we can use that to calculate our acceleration. Acceleration is change in velocity divided by time. Change in velocity is now 25. Our time is 10. So the acceleration is 25 divided by 10, which is 2.5 meter per second squared. So let's look at speed and velocity in action. Speed and so you can see this is Timmy, Bella, Carl, and Pete in action. Each one is moving at different speed. You can see Timmy is biking, is on a bike and is moving at 5 meters per second. Bella is also on a bike, is a biker, is also moving as 10 meters per second, traveling faster. And Carl is using his car, traveling at 20 meters per second, and this is using a jet or plane really faster. So who will reach that destination first? Assuming they are all going to the same place. I'll leave you to answer that. So let's look at motion in everyday life. So motion isn't just for our friends, it's all around us. Think about a train speeding by, an elevator going up, or a rocket launching into space. How do we measure these motions? So examples, a car can move at 60 kilometers per hour on the highway. A plane can move at maybe 800 kilometers per hour in the sky. That's very high. A child can move at 5 kilometers per hour running in the park. A bike can move at 15 kilometers per hour on a trail. So these are different speeds for different activities. So let's do some experiment. Let's test your scientific skills. Let's do some investigation on motion. So let's design your own experiment to measure speed, velocity, or acceleration. So we'll follow this step and discover the motion in our world. The instruction, choose an object. So select an object like a toy car, a ball, or anything that can move. Use a ruler or measuring tape to measure the distance the object will travel. Use a stopwatch to time how long it takes for the object to travel the measured distance. Then calculate the speed from those parameters you've measured, velocity or acceleration. Use the formula for speed as distance over time, velocity displacement over time, acceleration is change in velocity over time. And then record and present your findings. Write down your measurements and calculation. Create a simple presentation or report to share your findings with your class. So let's wrap up this topic. What are the key points we've learned so far? We've learned that speed is the rate at which an object covers a distance. The formula for speed is distance over time. So velocity is speed with a specified direction. Formula is displacement over time. The acceleration is the rate of change of velocity. So the formula is change in velocity over time. Wow, this is excellent. This is summary of what we've done in this class. Motion is an essential concept in physics that describes how objects move. Speed, velocity, and acceleration are fundamental aspects of motion, each providing different insights. So speed is a scalar quantity indicating how fast an object moves, while velocity is a vector quantity that includes direction. Acceleration measures how fast or quickly velocity changes over time. Thank you for staying to the end of the class. I hope to see you in the next class as we explore some other important topics in motion. Bye for now. It's your favorite teacher, Mr. Emmanuel. Bye.